All right, so this is our last review video for the test. We're going to focus on probability. I plan on going over those 5 problems from handout 8. I'm going to make up another just quick probability problem, and we're going to briefly talk about linear regression. So, before I get started though, absolutely go and do those problems if you have not already. To give you an idea of where you should be, you should have already done those problems 3 to 4 times. I do promise you, handout 8 is probably the hardest handout in my course. My students tell me that. And students have always told me if they were struggling with handout 8, that by the time they did it the 3rd time and the 4th time, it started to make sense. They started to see the patterns. You'll start to realize I'm very limited by what I can ask you, so all the problems kind of work the same. So you have to get to that point, and that way you'll know you're ready for the test. I don't often say you have to do my handouts 3 and 4 times. This is one that you might, and the answer key is there. I actually took the time to rewrite the answer key a few weeks ago, so it's very neat, very organized, and the first or second time through you may need to use the answer key to look backwards at the problem and let that help you learn. So make sure you're approaching handout 8 properly. Well, I guess I'll just go in order. I have my little list here. All right, start with number 11. 11 is one that students usually ask me about. It's not hard. I've always wondered for 10 years why my students don't like number 11, but that's irrelevant. Pepsi places winning symbols under the caps of 10% of all Pepsi bottles. So the probability of winning is 10%, right? Now, that was given in the problem. But if you want to stay super organized, you could go ahead and write, well, then I know lose is 90%, right? Because you're either going to win or lose. There's only 2 choices. So feel free to go ahead and write that because you never know what you're going to need in the problem. You buy a 6-pack. So, we always identify the probability and how many things are happening. What's the probability you lose, and I did cap that to make sure you didn't read it too quickly, lose no more than 5 times. So no more than 5. Oh, that's 5 and 4 and 3 and 2 and 1 and 0. I'm getting overwhelmed. That's an awful lot of different cases, right? So let me get organized and to what I call a table. Some students call it a T-chart. This problem is asking about lose. That title right there is critical. Now, remember we said you only have to show like the first 2 and the last 2. Do I lose 0 or 1? 2, 3, 4, 5, or 6. Okay, you can list them all if you want, but it's nice to be able to just list the first 2 and the last 2. This column is standing for probability. All probabilities add to 1. I'm going to go circle what the number 11, what they actually want from me. They want no more than 5 times. That would have been all of those numbers, right? I don't even know what those numbers are. And I haven't even taught, so in case you've had AP stats and combinations and stuff, that's how you would calculate those. I don't do that in my Math 220. So at this point, getting all of those probabilities is literally impossible from what I teach in Math 220. So there is no way you can approach it that way. Like on the tornado problem, handout 2, it technically was possible because I had given you the numbers there and you could just add them up. It was a waste of time, but you could do it. You cannot do it this way. So that's why we have that complement rule. 1 minus what I don't want gives me what I do want. 1 minus what did you not circle? 1 minus the piece that was not part of the problem. Now, if you've set up this little table in an organized way, you're going to be able to read what you don't want straight off of it. What did you not circle? 6 lose. See, that's why that title is so important. We're not talking about winning 6. We're talking about losing 6. I'll remind you that there were only 6, so I'm going to put the word all in there. You don't have to put the word all, but just trying to say there were only 6, right? 1 minus lose, 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 lose. 0.9 times 0.9. 1 minus 0.9 to the 6th power, because I'd have 6 0.9s multiplied all together, right? 0.9 to the 6. Stick that into your calculator. 0.4686. I want 4 decimal places. You're welcome to call it 46.86% if you want. All right. Let's go on to number 5. Yes, number 5 is the shortest problem on here. Again, I get asked about it a lot. Number 5. All right, you're in Vegas, you're tossing coins. It says head, tail, head, tail, tail, head. Or you get 2 choices here. These are 2 different things that the casino is going to let you bet on. It says, which sequence would you prefer, but explain by using probability. So basically, you got to calculate the probability of each choice. Now, we always assume a coin is fair unless we tell you otherwise, right? Now, here's the thing with number 5. I'm going to calculate in just a second. But if you just ask the general public right now which of these was more likely to come up, they're absolutely going to take this one, right? Because it looks more random. But let's see if that's the truth. Probability of a head is 0.5. Probability of a tail is 0.5. Probability of a head is 0.5. Each one of these, I'd have a 0.5. And of course, I'm multiplying, right? Each one of these has the exact same probability. 0.0156. So it does not matter which one you choose. That sequence is exactly the same probability as that sequence. Why the general public gets confused is because when they see this, we didn't say 3 heads and 3 tails. That's a completely different problem. I don't cover that in Math 220. But that exact sequence versus that exact sequence is the exact same probability. So it doesn't matter which one you choose. All right, let's go to number 12. Yeah, 12 looks pretty short. There's one piece, though, that some students get tripped up on. 12. Multiple choice test in Greek, and you can't read Greek. I'm just trying to get the idea that you have no idea from your own brain what the answers are. And it's A through D. Multiple choice, A through D. So kind of think SATs. I think they were A through D. There's 10 questions. So the first thing that stumps a student is, wait, they didn't give me the probability. Yeah, well, A through D. Those are 4 choices, right? So the probability just from randomly guessing, closing your eyes and just picking a letter, it's 1/4 or 0.25, right? So on something like when I tell you about a multiple choice, I do expect that you're going to be able to figure out that the probability of getting any question correct is 25%, 0.25. If it were A through E, it would be 1/5 or 0.2. If it's true, false, that's 0.5, right? 1/2. So there's a few questions that don't in your face tell you the probability, but they've given you enough information for you to figure it out. So this is the part that some students forget. All right, part A, you get all 10 correct. I know I did dashes and everything on the first video. I don't show all of that on my answer key, of course, but since this is still the beginning part of the video, I think I'm going to take the time to do it. I need to get all 10 correct. Correct, 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 correct. You, at some point, need to move past having to show the dashes, but until you get good at this stuff, feel free to show the dashes. Okay, what is the probability I get any question correct? 0.25. This is all multiply. I have to get the first one correct, and remember we talked about that and means multiply, and I have to get the second one correct, and I have to get the third one correct, and I have to get the fourth one correct. Okay, I'm already bored listening to myself. And I have to get the 10th one correct. 0.25 to the 10th power, which is good. I'm hoping you have practiced this 10 times by now. But if you're behind, let me try to help you out. Make sure you know where the caret button is on your calculator. 0.25 to the 10th. Everyone listen very carefully right now because I'm about to tell you a spot that I take off big points on test 2. Let me write down what my calculator is showing me. I don't know if I took the time to do this on the other video. That is precisely what my calculator is telling me. Now you can please put it in your calculator. You'll see it kind of takes up the whole screen, right? Here's the problem. Some students don't look at the whole screen, and they proceed to tell me that the probability is 9.5 or 9.5%, you know, something like that. And that is totally wrong. Now, if you tell me the probability is 9.5, I'm going to take off massive points because that means you missed a very big concept. This is supposed to be a decimal. 9.5 would be 950%. We can't go past 100%. Probabilities only go up to 1, right, in decimal form. So that tells me you totally missed all of that. So when you see that, you're like, wait, I'm not supposed to have a number bigger than 1. Keep looking. E to the negative 7. What that means is you'd have to pick this up and go 7 places to the left. 1, 2, 3, 4, 5, 6, 7, right? But to make your life easy, I've always said, I only require 4 decimal places. So to 4 decimal places, this is approximately 0 or 0%. I don't care about the form. I mean, if you want to show me 0.0000009, go for it. It kind of takes a while to type that. I only require 4 decimal places. So to 4 decimal places, as soon as I see negative 7, I'm like, oh, that's past 4 decimal places. We're talking 0. I need to erase this to give me more room for part B. You get at least 1 wrong. Now, there's that word again. This word is going to be with us the entire semester. Now remember, granted, it's slightly confusing that test 2 has 2 totally different topics. What we talked about on the normal distribution video was for, you know, the normal curve, the curve. It does not matter whether you're talking about greater than 2 or greater than equal to 2. But when you're doing the discrete distribution probability handout 8, it's absolutely critical. So this is 1 and 2 and 3. You have to make sure you know you're starting at 1, including 1, and then also going bigger. So I'm overwhelmed because I've got 1 through 10 here. That's too much for my brain to think about. So let's go to our little T-chart that you guys like to call it. This question is about being wrong. Okay, all I have to do is show the first 2 and the last 2. I went up to 10 now because I had 10. All probabilities add to 1. And I'm going to go circle what I want. I wanted all of this. Again, it's impossible. I don't know what all those probabilities are. So there's no way you can approach it that way. So we're going to have to do 1 minus, what did I not circle? Now this problem's slightly longer. 1 minus 0 wrong. Remember, I pulled the title. I'm talking about wrong here. Well, if you had been in the classroom with me, which of course we couldn't do, you would see me sigh every single time when I have the 0 case. I'm sure I did it in that video also. Because here's the problem. I can't do nothing. I could sit here and be silent. I could stand in front of you in a classroom and just stare at you. How do I do nothing? I can't raise things to 0 powers because that's, all equals 1, and that doesn't make sense. So the only time that you have to switch things is the 0 case. 0 wrong. Well, if I have 0 boys, I have all girls. If I have 0 fail a test, that means all pass a test. If I have 0 wrong, you must have got all 10 correct. This is just a synonym. I didn't go backwards or anything. 0 wrong. A synonym for that is, oh, wonderful, you got all 10 correct. I can do the probability of all 10 correct. Correct, 25 times. 10 times. Basically, that was part A that we calculated, right? So 1 minus approximately 0 is approximately 1 or 100%. Up to you as to which form you show me. So, you kind of already, I erased part A, but you start to see that if I have 10 questions, you're going to be raising something to the 10th power. Obviously, you have to think about it. You can't just say, oh, let me just raise 0.25 to the 10th, because sometimes you might need to go 0.75 to the 10th or whatever. But, you're never going to have a 9 exponent when we had 10 questions. That's probably the quickest way for me to know that you've done something wrong on the test. If I know I gave you an n equals 10, and you start using powers of 9, you've done something wrong. Let me add one more piece to this. This is not on handout 8, but I want to add a part C because I started rambling about powers and I want to make sure you know what I'm talking about. So we're going to call this star C because it was not originally there. What's the probability you get only the first 3 questions correct? Okay. We still had 10 questions. Somehow I got the first 3 correct. So, this is where most students start. They're like, okay, question 1 you got correct, and question 2 you got correct, and question 3 you got correct. You'll be lucky if I give you 1 point for that answer. Because, look, we had n equals 10. You only have a power of 3. Guess what? You forgot the other 7 questions. Apparently, you got the other 7 wrong. This is multiplication because basically I'm multiplying all 10 of those numbers. Multiplication, not addition. That's another common mistake I see. And see what I mean? Now you've taken care of all 10 questions. 3 plus 7 is 10. So that's a visual check to make sure you haven't forgotten something. On part A and B, I was just raising one number to the 10th. Here I had to split it up, but I still have powers of 10 total. So that's a real nice, quick way to catch mistakes that you might make. I guess I could stick this into my calculator. 0.25 cubed times 0.75 to the 7th. Okay, now he is a valid number, so please put that into your calculator. That is what I want to see. I don't want to see approximately 0 on that. It's not. To 4 decimal places, it's 0.0021. I think that was number 12. All right, let's go on to number 13. Okay, 10% of the population is left-handed. That is actually what the internet says. I mean, I don't know if it's exactly 10%, but that is a valid real-life number. All right, out of 10 people, so we got 10 people. What is the probability all are right-handed? So basically you've got 10 R's in a row. Again, you shouldn't, at some point you're going to be able to visualize this in your head. You're not going to have to take the time to write 10 R's in a row, but I'm just trying to be much more helpful on this video. Wait, what is right-handed? Well, if left-handed is 10% of the population, then we know right-handed is the other 90% of the population. Okay, 0.9 times 0.9 times 0.9 times 0.9. You get the idea. 0.9 to the 10th power, which is a nice number, 0.3487. So he was what we call the all case. Very easy. There's no T-chart needed. It didn't say at least one right-handed or anything. It just told me exactly what it wanted. It's what I call the all case. Out of 10 people, none are right-handed. Now make sure, please, that you know that none is a number. It's called 0. None are right-handed. So this is the 0 case. Oh, that's where I sigh, right? 0 right hand. I can't do that. I can't raise 0.9 to the 0 power. That doesn't make any sense. Oh, that means they're all left-handed. L, 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 0.1 to the 10th power, 4 decimal places, approximately 0. Now you notice, here I had the 0 case. Neither one of these problems are a 1 minus. One of the biggest questions I get is, how do you know if you're doing a 1 minus? Well, look back at 12b, just from a couple minutes ago, 12b as in boy. We circled a bunch of stuff. It was numerous cases. That's how you know you're going to do a 1 minus. But neither one of these was a bunch of stuff. It's like, it told me what to do. Okay, sure, I had to switch a 0 right to all left, but it just told me exactly what to do, so I did it. And then part C, I feel like I need to come up higher. And you see it, and let me keep reiterating. For part A and B, n equals 10, I got my 10 power, n equals 10, I got my 10 power, kind of not making a mistake. And part C, okay, they've upped it to 30. And let's pretend they all have names, right? Because they're humans. I just don't feel like telling you all 30 people's names. What's the probability only Alicia, Sam, and Mary are left-handed? So Alicia, Sam, and Mary, they are left-handed. I have 3 people. I don't really care what dashes you put them in, right? But if I could picture 30 people in front of me right now, I can point to 3 heads and say, you are left-handed. 0.1 times 0.1 times 0.1. Yeah, but wait, I was supposed to have an exponent of 30. I only have an exponent of 3. Oh, yeah, that means the other 27 people that I didn't feel like telling you their name must be right-handed. So you'd have 27 more of the 0.9s, representing the 27 people who are right-handed. Again, if you need to write out 30 dashes, pick spots for Alicia, Sam, and Mary. Put your 0.1s in there, and the other 27 dashes are going to have 0.9s. This is what it turns out to be. And technically 0.000058, which is technically 0.0001. But I'm going to be honest, on something like that, if a student wrote approximately 0, I'm not going to take off on a test. On the test, it is critical. You are not just going to read the question and tell me an answer. I will not give you any credit. This is probably the most important thing that I'm grading. I mean, I'm grading that also, right? But that's the most important for me to know that you did all the numbers correct. There are probably so many wrong ways to get that answer. I need to see that you got that answer from this work. So it is absolutely critical that you show me work. I do want to do number 6, but that's really a change of topic in probability. So before that, I'm going to make up a quick problem just to give you one more that you haven't seen yet. I think I'll write the problem. That way, if you want to try it, you can pause me and, before I go through it, since you haven't seen this problem yet. I have it on this tiny piece of paper. See, it's really easy for me to make up questions. All I got to do is tell you how many and then give you a probability. It can be about a car passing inspection, having an electric stove, having a cat, forgetting a chore. I mean, then I just kind of pick some random words over here, right? But they all are kind of the same. So part A is going to be, what's the probability at most 14 have a cat? Part B, probability only the first 3 have a cat. And then part C, probability at least 1 kid has a cat. So take a minute, write those down, pause the video, give it a try, then come back. So if you haven't had the time to write them all down, just pause your video right now while you copy it, because I'm about to do the problem. Okay, let's see. 15 kids. Have is 0.2, so I also know don't have must be 0.8, right? So I'm just kind of going through the problem. Okay, at most 14. At most 14, that's 14, 13, 12, 11. Oh dear, I'm getting extremely overwhelmed. So this is have, that's the title. I only have to show the first 2 and the last 2, and it was 15, so that's the 14 and 15. All probabilities out to 1. Now I'm going to circle what I want, at most 14. This is what I want. See immediately how I circled so many different cases? That's immediately how I know I'm going to do a 1 minus, because I can't add up all those numbers. I don't even know what those numbers are. So I'm going to read the complement rule off of this. 1 minus, what did I not circle? 1 minus 15 have a cat. Have, you know, 15 times. 0.2 to the 15th power. That should turn out to be approximately 1. But I'm not going to trust myself. Yes. Approximately 1 or 100%. Okay. Now this one, we've already done 2 in the video, so hopefully that one went. These are the easy ones, right? When I'm specifically saying like Mary, Sue, and John, or the first 3, or the last 2, or whatever, where you can imagine if it was in front of you, you could actually point to it. So the first 3 have a cat. All right, I got 3 people having a cat. But hold on, I was supposed to be having exponents of 15. I only have oh, the other 12 people must not have a cat. Let's see what that is. So these are the quick and easy ones. You don't want to make the easy ones hard and then get it wrong. Okay, this is good. Another scientific notation one. That is an answer. That is not approximately 0. That is going to be, we're going to get that precise in either test 3 or test 4 material. All right, I need to come up higher, so I'm going to erase if you need to pause me. Okay, part C, at least 1 kid has a cat. So again, this was about so I'm doing part C up here. Having a cat. So the first 2, the last 2. All right, at least 1 is 1 downwards. This is the longest problem I can give you. This is what I want. I can't do it. 1 minus, what did I not circle? 1 minus 0, having a cat. Oh, I'm sighing. It's the 0 case. I gotta do 1 extra step. The only time I have to do this step is the 0 case. I can't do nothing. 0 have must mean all 15 don't have. Maybe they all have dogs or something. I don't know. Don't have a cat. So 1 minus don't. 0.8, 0.8, 0.8, 0.8, etc. You don't want to hear me say that 15 times. 0.9648. Okay. All right, now we're going to switch gears. We're still in handout 8, probability. Going to the easier topic, the data tables. I'm going to try to add some to number 6. We can get a little more out of it. But let's look at 6. This would have been its own separate video. I think I did something with did you earn your master's, your bachelor's, your PhD, broken down by gender, so make sure you somehow did not miss that video. Fine, I'll do the 3 pieces on there, but I want to add a lot more pieces. Now, first of all, this chart, number 6, is easier because they did give us the totals, right? Make sure you know, like on number 2 and 3, I didn't give you the total, so the first thing you have to do is get the row and the column totals and then the grand total. But number 6, a little bit easier in that respect. Find the probability a randomly selected person is male. Now, they've broken up my males versus skilled and unskilled. Well, I don't care whether you have skills or not. I just want to know males. So, probability male, we need to add up all the males. Skilled males plus unskilled males. Apparently I have 750 males out of 1,000. So just don't forget there were 2 different spots the males were happening. Skilled. Now again, it didn't tell me if you were male or female, just that you have skills. So let's see. I have males who are skilled. That's my males that have skills. Let me go find my females. Then I had 100 females that had skills. I don't even know what skills are we talking about? Something to do with microprocessors, right? 600 over 1,000. I really don't like fractions. I mean, you should put your fraction, but then you should convert it, put it into your calculator, decimal form. I mean, that's 75%, that's 60%. I never care whether you give me decimal answer or percent answer. But if you give me the percent answer, you have to show the percent sign. That happened on test 1. If you just write 60 as the answer here, I really don't know what you mean. I don't know if you just forgot the percent sign or if you've done the problem completely wrong. So make sure if you're giving me percent, you put the percent sign. Satisfied. Okay. Oh, that's easy. See, the 3 problems here are actually probably a little too easy. We have 625 people that are apparently satisfied. .625. So that was supposed to be pretty easy, just, making sure you're okay with stuff. We're going to add some pieces, prep you a little bit better for the test. That one is nowhere near at the level of what we need for the test, but I'm still going to keep with number 6. I'm just going to add some pieces to it. Let's see, what did I want to do? So we're going to call this star D because it did not originally exist. Hold on. Oh. Probability a person is male or satisfied. So you have to be careful here. Here's that word or. He is such an important word. That means, so this goes back to that original video where I taught you the rules of probability. male or satisfied. So that means I got to include all the males, all the satisfied people. But if there's an intersection, that means I've double counted. So let's see. How many males do I have? Well, I had that 750, right? 500 plus 250. That's my males. 750 total. Okay. How many satisfied people do I have? Satisfied 625. But think about it. Those 500 people? Nope. Hold on. I did stuff wrong on my little post-it here. Hold on. Who did I double count? So I just counted up all the males. Oh no, I did it right. And I counted up the satisfied. I'm wondering if I should write on my piece of paper now. Maybe I'll do it in pencil. Okay. So this is a way that if this stuff confuses you with the word or, so I'm not trying to confuse you, I'm trying to help those who are confused. What I've done is just actually circle those 750, right? That's what I did there. Now I'm going to go circle who did I count up with the 625. And when you do that, you're going to realize you double circled. So when you go through on the satisfied row and you circle those, you're going to realize you circled the 350 and the 150 twice. You have double counted the satisfied males. You counted them here and you counted them there. You can't count them twice. So I'm going to get a denominator in a second, but 750 plus 625 minus 500. Let's see what that is. 750 plus 625 minus 500. 875 total over the 1,000. Because the or says males plus the satisfied minus anything you just double counted, which is called the intersection. All right, part E star. What's the probability you're male and satisfied? See, a lot of people don't read my English words carefully. This one had an or in it. This one has an and in it. You don't know if this is independent or not, so you can't multiply. You can't use the multiplication rule. This is a data table in front of you. It's even easier than that. Just go find where are the males who are satisfied? You've got, okay, now we don't care about the skills, right? There are 350 and 150. Right, males satisfied. There's some more males that are satisfied. Because I didn't care about your skill level, right? I just needed you to be male and to be satisfied. So both of those two entries. All right, we're going to add one more part. Is being male and being satisfied dependent or basically independent? So this is using the multiplication rule. Probability of male times the probability of satisfied. Does it equal the probability of male and satisfied? We have to check this. I have you do this in number 2 and 3 on this handout. So here's a third one that you'll get practice on. If it is equal, then we call it independent, but we have to check that, right? Okay, we've already done most of these numbers, but we're going to do it again. How many males do I have? I don't care anything about you. just that you're male. That's my 750 over 1,000, right? Okay, satisfied. I have 625. He's easier. Just satisfied total, 625. Okay, I'm trying to check to see if it's equal. I don't know if it is or not. Back to the males and satisfied. You have to be male and you have to be satisfied. That's that 350 and 150. I think that's what we just did. Okay, so this guy's easy. He's 0.5. Stick that into your calculator. All right, this is 0.46875. Does that equal 0.5? No, it does not. You're not rounding that. You're not talking about, oh, it's close enough. No, it's not equal. Thus, these are dependent because it's not equal. If it's equal, it's called independent. All right, we're doing good because we're going to take 5 to 10 minutes to just do a quick linear regression. Linear regression, again, is the easiest topic as long as you practice. Handout 5 through 7, I guess. Make sure you practice all the pieces. The parts that students miss are the slope interpretation specific, plus the very precise interpretation of r squared, the coefficient of determination. So keep that in mind. But again, I'm not going to do an entire problem because I think you have plenty to look at. I'm really trying to highlight one issue that I do see with some students. So let's just make up. So we're going to call this quick linear regression review. Emphasis on the word quick. I'm going to give you a tiny data set right now. Totally made this up earlier. Okay, so I want you to pause me in just a second. I want you to get your calculator. I want you to clear L1 and L2, just so we're all doing the same thing. Please put those 4 numbers in L1 and put those 4 numbers into L2. Okay, so go do that and come back. I'll make sure I did mine right. Okay. All right, so you're back with me. I want you to do these 2 pieces. Part A says predict grade based on hours studied. Part B says predict hours studied based on grade. So I want you to pause the video. I want you to go get those 2 answers, then unpause. I actually have to do my own work, so I'm not allowed to pause my video. All right. My main point of doing this is you have to make sure you think about the whole XYs, L1s, L2s, etc. So if you got it right, wonderful. If not, I'm going to talk through part A right now. So I'm going to the stat button. First of all, make sure you have R and R squared showing on your screen. If not, maybe I should run through that really quick. If you are missing R and R squared, you have to go to second of catalog. It pulls up 0. You're going to scroll on down to diagnostic on. Don't stop at the off. Diagnostic on. Hit enter a few times. Then when you rerun it, you'll have R and R squared. But back to this. How do you know if you're doing L1, L2, L2, L1? All right, we're doing part A. We're going to predict Y based on X, okay? So I'm labeling my variables, okay? So now I'm going to go to Stat, Calc, Choice 4, Lin Reg. I'm hitting Enter 1 time. Now here's the thing. I have an old calculator. The new calculator people, yours are more intuitive. Yours is actually easier. Let me talk about the old calculator people first. One more time. The cursor is blinking at you. Your calculator wants to know where did you put the X's, comma, where did you put the Y's. X's is hours studied. I put them into L2. So this is an L2, comma, L1. That comma is so critical. So I'm going to go second of 2. The comma is above the number 7, comma, second of 1. So you can see I have a complete sentence. Now, if you have a newer calculator, you would have been on a screen that says X list. Make sure your X list says L2. Then it would have said Y list. Make sure your Y list says L1. Hit enter. Put your A's and the B's where your calculator tells you to put the A's and the B's. Okay. Part B, what did I do? I switched the variables on you. This is Y. This is X. So when you go to your calculator, it wants to know the X's first. This one for part B is going to be an L1, L2. And that's how I get that. I think I'm going to stay with part B here just for 2 or 3 more minutes. And we're going to do a few more pieces to it. So I think I'm going to go ahead and erase part A. Everything I'm doing now is based off of C. Is based off of B. So let's call this C. Based on part B, let's practice slope interpretation. That's one that a lot of students get wrong. It's very precise. I put stars around it, probably a box. I put quotes around it. As X increase or decrease 1 unit, Y increase or decrease slope units. Just to give you that quick thing of what you're looking for in your notes. And I've left this. Okay, so X is grade. So as grade, now my slope is positive, right? So I can make them both go up or both go down. As grade increases 1, all right, I didn't really put units on this because I made this up too quickly. All my grades are in percent, so let's just do percent. Points, I don't really care. Hours studied increases 0.1 of an hour. Again, we did numerous of these on the other handouts, probably slightly more organized since I hadn't just made up something quickly. Then we did that, okay, well, what about if your grade increases 2? Well, it's kind of like algebra. You just multiplied by 2? Well, then hours studied would increase by 0.2, right? Or if I say, what happens if your grade increases a half? Well, you just cut it in half, so it would be 0.05. I think that's all I wanted to do with this one. This by no means is everything, right? Handout 5 and 7 kind of talk you through all the pieces like A through F or something. Handout 6 does quite a nice job of that also. Handout 6 number 4 has one that you really have to think about L1s and L2s and L3s. So if you're redoing all of the handouts and anything I do in lecture notes, then you should be good for the test. All right, I will see you soon.